Dear students, in this lecture video, we studied about the different terms which are used in the power plants, and we studied the significance of the individual terms. Now you see the first one is the energy. Energy is very important. How to calculate the energy generated by the every power plant? So we should know this term. The energy is nothing but the power consumption in the particular period of the time. That is, the power multiplied with the time is nothing but the energy. The unit of the energy is nothing but the kilowatt hour. Okay, that is kWh. Okay, and then the energy is nothing but the mechanical work done over the period of the time. Okay, that is in the form of heat. This is the definition of energy. And then what is the unit of energy? This is the term used in the power plant. The another term is work done. Work done is different. The work done is nothing but the distance traveled by the applied force. This is the work done. Okay, so what is the unit of work done? Is nothing but the unit, that is the Newton meter or joules. Then what is the definition of that? Means the work done. Another is the electric work is nothing but the product of voltage difference and the current flows in the conductor. That is nothing but the electrical work. So the electrical work, that is nothing but the power, is nothing but the product of voltage, that means ampere, and then the unit is watts and joules per second. Then the next term is the installed capacity. I already told in the previous lecture video, we are studying the economics of the power generation. What is the definition of installed capacity? The installed capacity is nothing but the designed power generation capacity of the power plant only is known as the installed capacity. So then the installed capacity, how expressed in terms of megawatt hour only, that is the energy generated per unit time. So the megawatt power with multiplied by, that is the hour, that is the energy generated per unit time. So therefore the installed capacity is expressed in terms of energy generated per unit time. The next term is used in the power plant is the power. The power is nothing but the rate of work or the work done per unit time. The power is expressed as megawatt or joules per second only. Because the ordinary domestic service only we are using the watts. In the lab we are using watts for calculating the power. But this generating plant is the huge amount of the energy generated power generation. So that's why the unit is megawatt. What is the basic unit of the power? Is nothing but the watts and joules per second. The next term is the heat rate. What is mean by heat rate? The heat rate is nothing but the amount of energy. Amount of the energy is expressed in terms of kilojoules. Okay, so that means that the fuel must supply to produce unit amount of the electrical energy. So the electrical energy is nothing but the kilowatt hour. So therefore the heat rate is expressed in terms of kilojoules per kilowatt hour or kilocalories per kilowatt hour. The kilojoules or the kilocalories, that means that is the amount of the energy, that means which are generated by the fuel only, and then per the unit electrical energy only. So therefore the heat rate is expressed in terms of either kilojoules per kilowatt hour or kilocalories per kilowatt hour. The heat rate, that means represents the overall efficiency of the power plant, because the losses also in terms of heat only. The turbine heat rate. What is the turbine heat rate? The turbine heat rate is nothing but the amount of heat steam was delivered to produce the unit of heat only. It is expressed in terms of kilowatt hour. Next, thermal efficiency. Okay, because the thermal efficiency is very important factor which are used in the power plant. So therefore the thermal efficiency is calculated, that means with the help of the amount of heat carried by the steam per unit amount of heat delivered through the fuel only. The next efficiency is combustion efficiency. The combustion efficiency is defined as the ratio of the amount of energy or the amount of heat released by the fuel to the energy contained in the burnt fuel only. This is known as the combustion efficiency. The next term is outage. What is mean by outage? The outage is nothing but the another name for shutdown of the power plant, either for planned maintenance or the planned outage or the due to unforeseen breakdown. That is the forced outage, that is called as the outage. Because in the power system we are using outage, that is the technical word. So outage is nothing but what is shutdown. When we are putting the shutdown, planned maintenance means what? Daily maintenance, weekly maintenance, monthly maintenance, yearly maintenance, quarterly maintenance, half-yearly maintenance, that is the planned maintenance. Planned outage, okay, some equipment we can put the checklist, after 1 month or 2 months we have to change, that's the planned outage. And then due to unforeseen breakdown, that means due to abnormal condition also the outages happened, this is known as the outage. Then next, availability. The availability is nothing but the fraction of the time a power plant is available for a generation. The power plant may be partially available due to the lack of operation of some components of the power plant. It is also called as the partial availability. The next term is interconnected grid system. Interconnected means more than one generating stations are connected, that is called as a interconnect. What do you mean by interconnected grid system? The connection of several generating stations are connected in parallel is known as a interconnected grid system. Nowadays all the power systems are interconnected power system only. Then next, how to calculate the load factor? The load factor is defined as the ratio of the average load to the maximum load. Okay, so the average load means the daily, for example you can take 24 hours. In the 24 hours what is the average load? Based on the load curve you have to calculate what is the maximum load. For example 10 megawatt is the maximum load, that is the maximum, but average load is 5 megawatt, like this. So from this range we can calculate the load factor. The next factor is diversity factor. The diversity factor is defined as the ratio of sum of individual maximum demand to the maximum demand on the power plant. The utilization factor is defined as the ratio of maximum load to the rated capacity of the power plant. The next factor is plant use factor. The plant use factor is defined as the ratio of kilowatt hour generated output to the product of rated capacity of the power plant. The number of hours for which the plant was in operation. This is very important. By using this formula only we have to calculate the plant use factor. This term is used in the power plant. The next factor is capacity factor. The capacity factor is defined as the ratio of average load to the rated capacity of the power plant. It is also called as a plant capacity factor. The another formula for calculating the capacity factor or plant capacity factor, total energy output in a period divided by rated capacity of the power plant. So therefore formula is capacity factor equal to average load divided by rated capacity of the power plant, that is equal to total energy output in a period divided by rated capacity of the power plant. Then demand factor. The demand factor is defined as the ratio of maximum demand on the power station to the total connected load which are connected to the power plant. This is the formula for calculating the demand factor of the power plant. How to calculate the reserve factor is, the reserve factor is defined as the ratio of load factor to the capacity factor. Already we know the formula of the load factor. Load factor is nothing but what? Average demand load divided by maximum load. Now the capacity, that means what? Average load divided by rated curve. From this end we can calculate the reserve factor. Then next we can calculate the plant reserve capacity. The plant reserve capacity is defined as the difference between the rated capacity of the power plant and the maximum demand on the power plant. The next, coincidence factor. The coincidence factor is defined as the ratio of that means capacity factor to the load factor. Otherwise the another formula, the reciprocal of the reserve factor. Reserve factor is nothing but load factor divided by capacity factor, but the coincides factor is nothing but capacity factor divided by load factor. That means the reciprocal of reserve factor. Students, these are the terms we are used in the power plant. In the next two lecture videos also we have to study the continuation of the different terms, that means which are used and considered for the power plant and their significance. Thank you student for watching this video.